cooling process all starts here at the bottom of the telescope with a device called a pulse tube. Inside these tubes are two pistons which move back and forth to compress the helium into the pulse tube. Since this movement would create a lot of unwanted vibration, these pistons have to move in the exact opposite direction with precision timing to cancel out each other's movement. These pistons move very quickly, just like a speaker, to create a low-frequency sound wave with a frequency of 30 Hz. This sound wave travels down the tube and gets compressed once it reaches the end, creating an area of higher pressure. Then, as it bounces back in the opposite direction, it expands, creating an area of low pressure before being compressed once again. If the next wave is sent out exactly as the previous one returns, it means the frequency perfectly matches that of the tube. This creates a standing wave where the areas of high and low pressure remain in the same place. By tripling the frequency, it causes the waves to combine and create a stationary wave with multiple areas of high and low pressure. Since temperature and pressure are related, this also leads to areas of high and low temperature. This alone wouldn't change the overall temperature because the hot and cold parts simply cancel each other out. But if there was a way to extract the hot parts, then the temperature would start to drop. And so 3 heat exchangers made of thin metal sheets are placed at the points where the hot and cold gas meet. These allow the gas to pass through whilst also absorbing some of its temperature, causing a heat gradient to form. The heat from the hot side is pulled out and sent to the radiators via a heat exchanger. Then, the cold temperatures on the other side are also drawn out. This causes the temperature to drop from 27 degrees all the way down to negative 256 degrees at the final heat exchanger. But how is this used to cool the sensors located at the opposite end of the telescope?